For Euclid's geometry, now we are going to discuss exercise problems. The first problem is given true or false. Only one line can pass through a single point. So, using a point, we can draw many lines. So, this statement is false. Why? The correct statement is infinite many lines can pass through a single point. This is a self-evident and can be seen visually by the student given below. That is, you can draw many lines using a single point. So at P, you can draw many lines. So here you have 4 lines. Similarly, you can draw infinitely many lines. So this is false. Second, there are infinite number of lines which pass through two distinct points. Using a 2 points, how many lines can possible to draw? Using a 2 points, we can draw only one line. So that is false. So you need to write false. Reason: the given statement contradicts the postulate one of Euclid's that assures that there is a unique line that passes through two distinct points. So using 2 points, we can draw only one line. Through 2 points P and Q, a unique line can be drawn. So next, third one. A terminate line can be produced infinitely on both the sides. So true. If at the point A and B, we can draw array right side and left side. So we need to consider Euclid's postulate 2. A terminated line can be produced infinitely. Using this, you can draw this. Next, if two circles are equal, then their radii are equal. So true, because two circles, consider two circles, we can conclude that when we make the two circles overlap with each other, we will get a superimposed figure of the two circles. So using the same radius, we can draw same size of circle. So we can superimpose to one another. So therefore we can conclude that the radii of both the circle will also coincide and will be same. So radii, it's a fuller form radius. Radius fuller form radii. So that's why we can conclude that both radii are equal. Next, in picture, if AB equal to PQ, PQ equal to XY, then prove that AB equal to XY. So this is also true, because we can consider the axioms. Given two distinct points, there is a unique line that passes through them. Given two distinct points, there is a unique line. Now we can conclude that AB, PQ and XY are the lines with the same dimensions, and hence same dimensions means AB equal to PQ, that is length. If AB equal to PQ, PQ equal to XY, then AB equal to XY. So reason, given two distinct points, there is a unique line, only one line possible to draw. So that's why the length of lines never change. So using this, we can conclude that AB equal to XY. Right. Next question. Definition we need to give. So using the lines. So first, parallel lines. Two lines are said to be parallel when the perpendicular distance between these lines is always constant. This is the definition of parallel line. Or we can say that the lines that never intersect each other are called as parallel lines. So draw the picture AB and CD, that the distance between AB and CD are equal. So we need to define line first in order to define parallel lines. Right. Next, perpendicular lines. Two lines are said to be perpendicular lines when angle between these two lines is 90 degree. So draw the perpendicular lines AB, AC and CD, that angle also draw. We need to define line and angle in order to define perpendicular lines, right? Line segment, CD. A line of a fixed dimension between two given points is called as a line segment. Fixed dimension means length of the line. It's fixed one. So a line of fixed dimension means length 5 centimeter, 6 centimeter, like that we are going to give a line segment. This is called as a line segment. We need to define line and point in order to define a line segment. Next, radius of a circle. The distance of any point lying on the boundary of a circle from the center of the circle is called as radius of a circle. The distance of any point lying on the boundary of a circle, lying on the boundary of a circle from the center of the circle is called as radius of a circle. So this is also a definition. We need to define a circle and the center of a circle in order to define a radius of a circle. So what are the things needed? Center, definition circle, and center of a circle, right? Square. A quadrilateral with all four sides equal and all four angle of 90 degree is called as a square. So like that we need to write a quadrilateral with all four sides equal and all four angles of 90 degree is called as a square. So here A, B, C, D is a square, right? Next question. Consider the two postulates given below. Given any two distinct points A and B, there exists a third point C which will between A and B. There exist at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulate? Explain. So, answer. We are given with the following two postulates. Given any two distinct points A and B, there exists a third point which is between A and B. Next one also given. The undefined term is given postulates are point and line. The undefined term. The two given postulates are consistent. Answer is consistent. And they don't refer to similar situation and they refer to two different situations. It's not consistent to one another and also it explains different situations. We can also conclude that it is impossible to derive at any conclusion or any statement that contradicts any well-known axioms and postulates. So we can give the contradict statement. We can also conclude that is it is impossible to derive at any conclusion or any statement that contradicts any well-known axioms and postulates. That is, the two given postulates don't follow from the postulates given by Euclid. It's not followed by the postulates. But the two given postulates can be observed following from the axiom. It's followed from the axiom. So given two distinct points, there is a unique line that passes through them. So using axiom only we can conclude this. It's not a postulate. Right. Next. If a point C lies between 2 points A and B such that AC equal to BC, then prove that AC equal to 1 by 2 AB. AC equal to 1 by 2 AB. Explain by drawing the figure. We are given that point C lies between 2 points B and C such that AC equal to BC. Write the given statement. We need to prove AC equal to 1 by 2 AB. Let us consider the given below figure. Draw the line AB in between, draw the point C. So we are given that AC equal to BC. So what we can conclude using an axiom of Euclid says that if equals are added to equals, the wholes are equal. If equals are added to equal, the wholes are equal. Let us add AC to both sides of equation. So AC plus AC equal to BC plus AC. Add both sides AC of the equation 1. An axiom of the Euclid says that things which consist coincide with one another are equal to one another. Things which coincide with one another are equal to one another. So we can conclude that BC plus AC coincide with AB, or AB equal to BC plus AC, or AB equal to BC plus AC. Right. An axiom of the Euclid says that things which are equal to same thing are equal to one another. From equation 1 and 2 we can conclude that AC plus AC equal to AB, or 2AC equal to AB, 2 times of AC equal to AB. So like that we need to write this proof. For that, an axiom of the Euclid says that things which are halves of the same things are equal to one another. Things which are halves of the same thing are equal to one another. So that is AC equal to 1 by 2 of AB. Like that we can write. So the proof we are going to write by using your axioms. So write the proof like that. Next. In the above question, point C is called a midpoint of line segment AB. Prove that every line segment has one and only one midpoint. So you needed to tell C is a midpoint, means only one point is possible between the 2 points. We need to prove that every line segment has one and only one midpoint. Let us consider the given below line segment AB and assume that C and D are the midpoints of the line segment AB. C and D, the midpoint. So we are going to consider two midpoints. If C is the midpoint of the line segment AB, then AC equal to CB. Then AC equal to CB if C is the midpoint. Next. An axiom the Euclid says that if equals are added to equal, the wholes are equal. So add AC. So add AC on both sides, AC plus AC, right side CB plus AC. From the figure we can conclude that CB plus AC will coincide with AB. So AC plus AC equal to AB, like that. An axiom of Euclid says that things which coincide with one another are equal to one another. That is AC plus AC equal to AB. AB plus AC equal to, so that is AB. An axiom of Euclid says that things which are equal to the same things are equal to one another. So that is, we needed to compare 1 and 2. So let us compare equation 1 and 2 to get AC plus AC equal to AB, or 2 times of AC equal to AB. If D is the midpoint of the line segment AB, then AD equal to DB. Then AD equal to DB. An axiom, the same thing, add AD on both sides, AD plus AD equal to DB plus AD. DB plus AD will coincide with the AB, no, in figure. So that's why by Euclid's axiom, things which coincide with one another are equal to one another. That is, AD plus AD equal to DB plus AD is nothing but AB. So write this thing, AB. An axiom of Euclid says that things which are equal to same things are equal to one another. So compare these two things. So AD plus AD is 2AD. That is, AD plus AD equal to AB, no? So 2 times of AD equal to AB. Now compare 2 times of AD and 2 times of AC equal to AB, this thing. So an axiom, that is, we are going to compare 2AC equal to 2AD. Things which are house the same things are equal to one another. So cancel 2. So AC equal to AD. So therefore we can conclude that the assumption that we made previously is false, and a line segment has one and only one midpoint. The assumption is false because of two midpoints. This is our assumption. C and D is the two midpoints. That's why. So, my dear students, try to write the proof as it is, because this is well known things already. We know that which are true, which are false, and how to represent the midpoint, how to represent the point in between the two lines. Like that we can know that parallel line, perpendicular line, and radius, everything. But we how to represent this thing by using a mathematical proof. This is the important, by using your axiom and postulates. My dear students, try to study this proof and also write neatly in your note. Thank you.